occasionally we'll need to look at things that are curved differently in the different dimensions. So let's look at a couple objects and see how we can describe the way they're curved using the total curvature. So we'll use the symbol H for the total curvature. And the simplest case is a sphere. So we draw a sphere, and we can see that whether we're looking in the x dimension or the y dimension or the z dimension, any two orthogonal axes that we pick, we can see that R1 is equal to R2. And H is going to be defined as the total curvature, and curvature is reciprocal to radius. The more tight the radius is, the higher the amount of curvature. So in this case, since we have two radii that are equal, the total curvature for sphere is just 1 over r plus 1 over r, so it's 2 over r. If we have a cylinder, something like this, a Coke can or something like that, we can see we've got a radius, we'll call it r1, and that's in the xy plane, but what about the z plane? We can see on the z-axis there's no curvature at all. Another way of saying that is that the radius of the circle that would be curved like this would be infinite. So it's 1 over r plus 1 over infinity, or just 1 over r. Okay, so it's half as curved if we have a sphere that has the same radius as the cylinder. We can see the curvature is twice as much on the sphere as it is for the cylinder. And the other case you might have is something where the curvatures are opposite in sense. So you might have something that we'll call this R1, and here we can see that the center of curvature for R2 is outside. If this is inside the object, this is outside the object. So we're going to say if we're inside the object, that's a positive curvature, and if you're outside, it's negative. So in this case, H would be equal to 1 over R1 minus 1 over R2. So it's possible, depending upon the sizes of R1 and R2, to actually have a curvature equal to 0, even though the surface is curved. So to give you an idea of something from the real world that has complex curvature like that, we can see, if we look at the top of this cooling tower, that in the xy plane, we have positive curvature. It's curved towards the inside of the center of curvature is inside the cooling tower, so the center of the circle might be something like that. So that center of curvature is outside the cooling tower, so that would be a negative curvature.